So welcome students. So let us look at the topic of binomial theorem. So this topic of binomial theorem basically deals with the expansion of x plus y whole power n if n is any number. That is, by the end of this topic, you will be able to expand x plus y whole power n for positive integral index, that is, you will be able to expand x plus y whole power any positive integral index. If I ask you to expand x plus y whole power 5, you would be able to expand this. So till 10th class, you know how to expand x plus y whole square and x plus y whole cube. Till n is equal to 3, you know how to expand this. But in this topic, we'll try to analyze how to expand x plus y whole power n if n is a large number or for any positive integral index. And once you complete that, this involves the basic part of this binomial theorem. And after that, you'll also understand how to expand x plus y whole power n for negative integral index. That is, you will be able to expand something like x plus y whole power minus 5 also. So this has been not done till now for you in lower classes. This is the thing that you learn newly in 11th class. And lastly, you will also understand how to expand x plus y whole power n for rational index. So if I have to broadly divide this topic into 3 parts, so I can divide it like this: how to expand x plus y whole power n for positive integral index, how to expand it for negative integral index or rational index. So the basic part of binomial theorem constitutes the expansion of x plus y whole power n for positive integral index, that is 1, 2, 3, 4, so on. So to understand how to expand x plus y whole power n for positive integral index, so let us look at the things that we already know. So what are the things that you already know? So you know that if n is equal to 0, the expansion will become x plus y whole power 0, which is nothing but 1. So you know that any number power 0 is 1. So for n is equal to 1, also you know the expansion x plus y whole power 1, that is x plus y. So x plus y whole power 1 is x plus y, there is no doubt about it. For n is equal to 2, have x plus y whole square. You also know the expansion of this. What is the expansion of x plus y whole square? X square plus 2xy plus y square. A square plus 2ab plus b square, you know the expansion. So for n is equal to 3 also, so you know the expansion, x plus y whole cube, that is x cube plus 3x square y plus 3xy square plus y cube. So till n is equal to 3, you know the expansions in your lower classes. So now we are trying to analyze if there is a pattern that is being followed as you go to higher and higher numbers. So if n is equal to 4, you have x plus y whole power 4. So if I ask you to find x plus y whole power 4, you will be able to find it even without binomial theorem. So how do we do it? So you just need to multiply x plus y whole cube with nx plus y again. So if I ask you to do that, so it will be something like this: x plus y whole cube into x plus y, that is equal to x cube plus 3x square y plus 3xy square plus y cube times x plus y. So if you multiply this, you see that you get an x power 4 term. So you get an x power 4 term plus then x power 4. After x power 4, you have 3x cube y plus x cube y, that is 4x cube y plus. Then if you see, the next term will become, so you have multiplied this with this, and this multiplication has been done, and this multiplication has been done, and this multiplication has been done. and afterwards you have to multiply this with this, that is 3x square y square plus again 3x square y square, you have 6x square y square. So, you have multiplied y with this and also x with this. Now, what is remaining? 3xy cube plus xy cube, that is 6x square y square plus 4xy cube plus lastly you have y power 4. So, in this way you can also get the expansion for n is equal to 5. So, you just need to multiply x plus y whole power 4 with x plus y. But if you have to do this, it will be very difficult to get the expansions. So, is there an easy way to get the expansions? That is the question that we are going to deal with. So, my aim will be to find an easy way to expand x plus y for some positive integral index. To do that, the first thing that I do is, I will try to observe if there are some patterns that are being followed by these expansions. So, I will observe the following. The first thing, so I will try to count the number of terms in the expansion. That is the first thing that I do, number of terms. So, if n is equal to 0, you have one term. So, if n is equal to 1, the expansion contains two terms x and y. If n is equal to 2, you have 3 terms. If n is equal to 4, you have 4 terms. If n is equal to 3, you have 4 terms. If n is equal to 4, you have 1, 2, 3, 4, 5 terms. So, I have observed that whatever value of n, the number of terms is equal to n plus 1. So, I hope this is clear. And the second thing that I observe is, so if I take any n, let us take n is equal to 4, observe each of these terms. Observe each of these terms. So, can you see the effective power of the variable? Effective power of the variable. Effective power of the variable is the sum of powers of all the variables that are present. So, if you take this term, the variable present is x power 4. So, the effective power is 4. And in the next term, x has a power of 3 and y has a power of 1. So, the effective power here is 3 plus 1, which is equal to 4. Similarly, in the next term, the power of x is 2, the power of y is 2. So, the effective power is again 4. X power 1 y cube, the effective power is again 4, the effective power is again 4. And if you go to the expansion of x plus y whole cube for n is equal to 3, so if you observe, the first term is x cube, the effective power is 3. X square into y power 1, the effective power is 3. X power 1 into y square, the effective power is 3. Y cube, the effective power is 3. So on. So, if you observe this very important pattern, the effective power of variable in the expansion of x plus y whole power n is always equal to n. So, you won't get any other term whose effective power is not equal to n. That is, you have a very clear idea what are the terms that you expect in x plus y whole power n. Example. So, once we observe this, you can see that if I have x plus y whole power 7, x plus y whole power 7. So, you know what are the terms that are present in this expansion. So, the first observation is you have 8 terms. The second observation is that every term should have an effective power of 7. So, what are the terms that you can expect? You can expect an x power 7 term. You can expect an x power 6 into y term, x power 5 into y square term, x power 4 into y cube term, x power 3 into y power 4 term, x square into y power 5 term, x into y power 6 term, and finally y power 7 term. So, you can have only terms correspond to these expressions 1, 2, 3, 4, 5, 6, 7, 8. So, for n is equal to 7, you have 8 terms and these are the 8 terms. So, you won't get any other terms. So, this is a very important conclusion that we can get from this. So, now there is only one thing left. So, if you can find the numbers that come, if I can find the coefficients that accompany these terms, my expansion is done. So, effectively if I want to do the expansion, I just need to find the coefficients of this. So the next question becomes, can I find the coefficients? So if I can somehow find the coefficients, my binomial theorem is done. The basic binomial theorem is done. So let us look at how we can get the coefficients. So to observe the coefficients, we need to find the patterns involving coefficients. So now let us remove the terms, let us solely concentrate on the coefficients. So let us see if there is a pattern in the coefficients. So now, let us solely concentrate on the coefficients. I have written just the coefficients, I have removed my x and y's because I am trying to analyze the coefficients. Now these are the coefficients 1, 1x plus 1y, 1x square plus 2xy plus 1y square, 1x cube plus 3x square y plus 3xy square plus 1y cube, so on. So can I see a pattern in these numbers? So there is a pattern which is attributed to a mathematician, Pascal. So you have something called, Pascal has observed a pattern in these numbers. So the pattern being something like this. So if you draw a triangle, you can see that all the peripheries are made with 1s and the numbers which are in between. So 1 plus 1 is becoming 2 and 1 plus 2 is becoming 3, 2 plus 1 is becoming 3, 1 plus 3 is becoming 4, 3 plus 3 is becoming 6, 3 plus 1 is becoming 4. You can see that any coefficient is the sum of the coefficients in the previous line. So this was the pattern observed by Pascal and this pattern is called Pascal's triangles. So let us hope that this pattern works. So it's not necessary that if I can see the pattern in the first 4 terms, it should continue. But Pascal has observed that this pattern is getting continued. So for n is equal to 5, if I have to write the expansion for n is equal to 5, I know the terms which are there. So I just need to find the coefficients. I can very easily find the coefficients using Pascal's triangles. That is, the first number will be 1, there is no doubt about it. The second number will be the sum of these two, that is 5. The third number will be the sum of these two, 10. The fourth number will be the sum of these two, which is again 10, 5, and the periphery will be 1. So these are the 6 coefficients that you get. And if you want coefficients for n is equal to 6, you just need to follow this pattern. So using this pattern, you can sequentially go and find the coefficients for any n. So now I know the method to find the coefficients. But can you see that it's not a very good method? So this is a pattern based method. But this is not very good because if I have to expand x plus y whole power 100, I have to write this table up to 100 terms, which is very difficult. I have to start with x plus y whole power 1 and write all the terms till I get x plus y whole power 100. So I cannot directly get the expansion for x plus y whole power 100. So Pascal's is a pattern based method where if you want to find the expansion of some number, you have to write all the expansions corresponding to the previous numbers. So you should not be very happy with this method. This method is exciting, but you should not be very excited about this method. So now to find the coefficients still easily, let us look at a mathematical method. So mathematical logic based method. So let us look at the logic by which we can get this coefficients very easily.